Hello there, my name is 𝘁𝗵𝗶𝘀. In this short video, I'm going to give you an overview of how to value a fixed rate bond using UnRisk for Excel. Before we dive into how to do this in Excel, let's open the documentation up in our browser. You can do that from within the UnRisk for Excel plugin. And I'll take you to this place here where you can navigate into Instruments and Valuations, Fixed Income, and you'll find the instrument Fixed Rate Bond. And like so many objects which are described within UnRisk, it starts off with a general description, the typical properties that are required to configure the bond, as you might expect: redemption, coupon properties, cash flows, embedded call and put optionality, for example. Then you have a description here called the instrument schema, which details the exact properties which are required to configure the instrument across all environments, whether Excel, JSON, C#, whatever. And here we have, for example, a business day convention. You can see that it's required. And if you expand this element here, you'll see the possible enum elements for this field. Further down, and I'm not going to go into too much detail in this video, you'll see a description of the methodology that's possible for valuing the bond, the types of cash flows that can be returned in the analytics, a description of the valuation schema, which we'll see in Excel in a moment, but most importantly, some typical examples to help you get going. Here's an example for a bond without optionality, valuation with yield curve, which is going to be really appropriate to us. Here you'll see some typical example for a typical kind of bond, and we describe two ways of doing it, one using Excel and one using JSON. So click on JSON, you'll see this is the JSON representation of the instrument above. Of course, you're welcome to look at the examples in Excel that are provided with UnRisk, but in this video here, I'm going to start from scratch and show you how to get going. So let's now head over to Excel and see how to do it. So in time-honored fashion, here is one I prepared earlier. Ultimately, I'm going to show you how to create this spreadsheet here, which values a fixed rate bond, or specifically determines the credit spread to match the market value of the bond on a given date. But first of all, I'm going to show you how we got here. So if I start from a blank sheet as I have here, and I open up the add-in, obviously I get the welcome documentation here first. But if you navigate to Tools, you'll have here this item called the Schema Discovery Tool, and this is very cool, this thing. So I can look for fixed rate bond there, and you'll see some possible ways in which we can discover the schema. This will make sense in a second. I'm going to choose the option to transpose. I'm going to pick somewhere I want to configure the bond in my sheet, and I'm going to say I want an example of fixed rate bond with auto coupons. And there we go. What this does is it looks at the UnRisk schema and finds out the properties of a fixed rate bond which are minimally required to construct an example. You can do other things like insert example values or try different configurations. Perhaps by the time you look for this yourself, this is something we're always working on, the number of options here will change. But this effectively digs into the documentation, if you like, the schema, to find out what the properties are required to configure the instrument or the object in question. Now, hopping over to the exercise, this is what we're going to do today. We've now got a 1 5/8 UK gilt maturing in 2071. It has a particular ISIN. And we're going to evaluate it for the 16th of January 2024. Now, if I dig around the internet, various pricing sources, it's possible to find that the clean price, that's to say one without accrued interest on this date, is 0.4626. It's not very surprising because it's a relatively low coupon and it's 50 years to maturity. So the discount factor, given current market conditions, which are approximately 3 or 4% at the moment for UK interest rates, means that this is heavily discounted. Now here are the required properties of the bond. I happen to know, because I have the pleasure of working quite a lot with UK gilts in my life, that there are some other properties which are useful, such as the coupon rolling day, which determines that the coupons are always paid on the, or at least recognised on the 22nd day of each month. UK gilts also have an ex-dividend or ex-coupon period of 6 working days. That's given by ex-dividend days are business days, flag, and the value 6. And there's also the possibility to specifically configure how the yield to maturity is calculated, which may be different from the bond's properties. Here I've taken the liberty of inserting from the term sheet, or what you can find on the DMO website, the properties of the bond, except for one thing, the holiday calendar. For this, I can dig into the UnRisk embedded data here. We have a number of holiday calendars which are provided for convenience. And to get to that, I go equals UnRisk.getHolidayCalendar United Kingdom. Et voila, it returns an object holiday calendar. So the next thing I need to do is to construct an object of type fixed rate bond. Well, because we have this famous build formula, I just need to give it the range where the type of the object is mentioned in the top left-hand corner. There we go, we've constructed a fixed rate bond. And right, next up, we want the price. Now, I said we were going to value the bond. Well, we're not going to value the bond from nothing. Actually, what we're going to do is calculate the credit spread given the price and given a curve. So I now need to construct a price. Now, we're given that this is the clean price that we see in market data. So I actually need to construct a price object. And to do that, I use UnRisk.build S, because it's a particular type of thing. I'm going to construct a price of type clean price. Again, you get familiar with this, but you'll see it lots of places in examples in the documentation. And I give it as the third argument the value of this price. And there we go. I now have a price, and I can see there its JSON representation there. Now we're going to value the bond, and here are in dark green the required parameters, and the pale ones are optional, and we're not going to use those optional parameters. We don't need them. But what we do need is an interest rate model or a curve. We're going to need a yield curve. We need the instrument itself, the target price, because we're valuing the bond given the price to calculate the credit spread, the valuation date, and what kind of output values we want. Now, normally you'll see that this field here is just called interest rate models and curves. To value it specifically just under a yield curve and not a stochastic model of rates like a whole weight 1D model, I just need to give it a yield curve. But where's my yield curve? I need to construct that. Well, if you head over when you start using UnRisk and you look at the utilities and one of the previous videos I've made, you'll see how we can make a yield curve. But just to recap, we need to have a definition. So I've constructed a definition here for Treasury or UK curve. So UnRisk.build. Oops. Give it this range here. I'm going to have a flat curve of 5% rates. In another video, we're going to show you how I actually construct a UK gilt curve from gilt prices, but let's just take a flat 5% curve here. And to construct the yield curve, I need the yield curve definition, so I assign it that thing there. I need the reference date, which I got up there, and I need tenors and rates. And the best way to construct that is UnRisk.build tenors and rates, and I just give it the array of tenors and rates, which I've got here. So 5% constant forward rate, flat. And now I construct the yield curve for the specific date. .build s or build, and I give it this range here. There we go. We've got a yield curve. So again, I can see its JSON representation here and the tenor and rate array defined within it. Okay, now we're ready to cook. So because we're valuing this with just a yield curve, we actually adjust this field here to be interest rate models and curves .yield curve, and I give it the yield curve as a reference. There we go. I need the instrument. Well, we've constructed that here. I'm not worried about these fields here. I need the target price. Well, we constructed the price object there. I need the valuation date, so I give it the dates. And output values. If you go to the documentation, you'll see all the possible output values that valuation of a fixed rate bond can produce. And generally speaking, it's probably good practice to be specific about what output values you actually want, because otherwise UnRisk will calculate everything. And for some instruments, in some conditions, for example, sensitivity to changes in interest rates, this can be pretty expensive computationally. But hey, let's go for it and just say all. Now we construct the object UnRisk.build, and we give it the whole range. It doesn't matter that the optional values are there, they just got empty arguments and the plugin will ignore it. And we've constructed a task for UnRisk to go and value a fixed rate bond. At this point here, nothing has actually gone to be executed in the engine. It's just constructed the JSON. Now let's solve it. So UnRisk.solve, and I give it this thing here, this object, and it returns a result. It's cheating to look on the right hand side to see what the result is. Now I'm going to unpack this result into Excel. There are a number of ways of doing this. You can fully expand it. That means kind of convert what's behind the scenes into Excel form. And so you do UnRisk.expand and just give it results. And there are various arguments that you can use to control the formatting and the way it's shaped. And there we go. We've got everything. Look at all of this. We have plenty of data here, including many cash flows that are and sensitivities that are useful to people in different contexts. But I just want the implied credit spread. So I would do equals this dot, look at this. I now have this structured data that's known to Excel, and I can just extract the field I want, implied credit spread, and there we go. Which is how many basis points? Negative 68.5 basis points. So there we go. We've completed what we set out to do. Now, if we were feeling, if we were in a real hurry and just wanted to see how that depended on a change of interest rates, and I just put that to 4%, for example, I don't have automatic calculation turned on, so this number hasn't yet changed. But remember this number, 68.5 basis points. If I head over to formulas and then say recalculate the sheet, now it goes 31.48, which makes sense. We've dropped the curve down by 100 basis points, and now we are 31 basis points above where the curve is, whereas before we were, whatever it was, 68 beforehand. So there you go. That's a very quick example. You can see how you drag in the data from the term sheet, construct the Excel objects here, price them, construct the valuation, and then extract the results. So I hope you found this video interesting, informative, and you're ready to start taking on your own challenges with UnRisk EXCEL.